Good evening. Good evening. Tonight's lesson is 10.5 and it is over circles and angles. You watched the video on vocabulary. There's a lot of vocabulary here. But basically the objective is we want to solve angles as they relate to circles and arcs. Okay? So let's start right in with ones that we have already learned, and that is central angle. Central angle. If I have a central angle of 100, then its arc measure is the same. And if I have the arc measure, then I know the central angle, and they are the same always. Okay? So that's the relationship there. You're already familiar with that rule. So let's move on to inscribed. We've already looked at inscribed angles as well. Inscribed angles is 1/2 the intercepted arc. So here's my inscribed angle, 50. It's just half of the central angle that shares the same arc of 100.86, so it's cutting that in half. Okay? So central is the same. Inscribed angle, where the angle vertex is right on the circle, is 1/2. We're going to see that this is a pattern, because we're going to look at now at a tangent chord. Notice where the vertex of a tangent chord is. It's on the circle as well, just like the inscribed. Hey, and guess what? You've got the same rule. The arc measure, if you have your arc measure, cut it in half and you'll have your angle measure. So what angle am I referring to here? Let's be clear about that. The angle that I'm referring to is the measure, this angle right here, is going to be 1/2 this arc measure. Half of that. Okay. Two chords. Remember the chord angle gives us an angle inside the circle, so that's kind of key. We're inside the circle here. Let's take a look at some measurements. So arc AD is 95.82. Arc CB is 99.88. What we want to be able to solve now and go in between arc measures and the angle measures that create them, we have the following rule. Angle formed by two chords intersecting inside a circle is 1/2 the sum. A number that is going to be very popular is one that 1/2 is popular, and then we have to pay attention. In this case, we're going to take a sum. So what that means is I am going to take this arc, 95.82, and sum it with this arc, which is 99.88, and then I'm going to take half of it, divide it in 2, and I get the angle 97.85. I get my angle. And that's not a central angle. That's just the angle of the chord. Let's look at the two secant. So now I've got two secants. Where's the angle at? Notice it is not on, but it is outside the circle. It is outside the circle. You can see your rule right here. Again, I said that a number that's going to come up a lot is 1/2. 1/2, in this case, it is the difference of the arc measures, the intercepted arc measures. So if I take this arc measure right here, that arc measure right there, which is 94.97, and I subtract this intercepted arc here, 30.9, and I divide that in 2, I will get this angle here, which is 32.03. So let me write that out. I'm taking the difference of the intercepted arcs, dividing it by 2 to get 32.03. This is going to be the same rule for any vertex that lies outside the circle. So, for example, our next one is the tangent secant. I've got an angle that has been created by a tangent and a secant, this angle here. Well, the tangent and the secant also cuts the circle into 2 arcs. This blue arc and this red arc. That circle has been divided into those 2 arcs. Again, I am going to take 1/2 the difference. 1/2 the difference of the arcs. So in this case, I've got arc AED is 168.38. Arc AC is 77.87. And my angle here is 45.26. How did we arrive at that? We took 168.38. We found the difference, or we subtracted 77.87. Then we divided all that by 2 to get 45.26 degrees. Okay, let's move on. There's one more situation where a vertex is outside the circle, and that is our tangent-tangent relationship. Notice that it also divides the circle into 2 arcs. Okay? In fact, the whole circle is divided into exactly 2 arcs. The rule, just the same. 1/2 the difference of those arcs. So, this arc measure, according to Geometry Sketchpad, is 250.3. The smaller arc is 109.7. And my angle measure is 70.3. How did we arrive at those? We took 250.3. We subtracted 109.7. We divided it all by 2, and we got 70.3 degrees. We took 1/2 the difference. Now, let's summarize this. A lot of rules to keep track of, and I think it's best if you think about it in these 3 different bins. Inside circles, vertex inside, vertex on, vertex outside the circle. Okay? The key number that we keep using is the number 1/2. 1/2 what? This is 1/2 the sum of the arcs that are intercepted. Okay? That will give us these angles. This one is just 1/2 the arc. I just take the arc, cut it in half, take the arc, cut it in half, and we get the angle. And finally, the last one was 1/2 the difference. Difference from that arc minus this arc got me that angle. This arc minus this arc gives me the angle. This arc minus this arc gives me the angle. Divided by 2, I'm sorry. I need to subtract them and cut it in half, and I'll get the angles. Okay. Let's look at an example. We should be able to solve for all the angle measures here in this sketch. Okay, given the angle measures provided, we should be able to find all of the rest. All right. The first thing I notice is that let's start with the easy ones. Well, if this is 65 degrees, its vertical angle is also 65 degrees. So let's mark that. That must be 65 degrees. And if that one is 65 degrees, then its complement, or its supplement, I'm sorry, is 115 degrees, because they have to add to 180. So that's helpful. That 4 is easy. Those 4 angles are easy. Next, I'm going to use this 24. I noticed that 24 is going to use this arc here. If I knew this arc, which I don't, so I'm going to call it X. If I knew what that arc was, and I knew what this arc was, which I'll call Y, I should be able to find 24. So let's write an equation. What do? Well, the vertex is outside the circle, so I'm going to take the difference, X minus Y divided by 2 equals 24. Okay. Using X and Y and 65, what is the relationship between X and Y and 65? It is X plus Y divided by 2 equals 65. And now we have a system that we can solve. To write this a little bit more simply, I guess, I've got X minus Y, I'm going to multiply by 2, equals 48. And on bottom, I've got X plus 2 equals 130. Sorry, X plus Y equals 130. You know, linear combination makes a lot of sense for this one. I'm going to add those up to get 2x, add these up to get 0, add these up to get 178. Divide by 2, 89 degrees. X must be 89 degrees. And what does Y have to be? Well, again, I can come back here. If X is 89, I can take 130 minus 89 to find that Y must equal 41 degrees. All right. Now, look at for some of the other ones we know here. So this is a central angle. So if that's a central angle, its arc is 89. Therefore, that one's 89 degrees. Done with that one. Looking at this angle here, the vertex is on the circle, and it intercepts this 89. So it's 89 divided by 2, cut it in half to get 44.5. Similarly, this angle here is going to be 44.5 because they intercept the same arc that's 89 degrees, and they're inscribed angles. Coming from the other direction, I see these are inscribed. They intercept a 41 degree angle, so that leaves 20.5 because I cut it in half. This one also is 20.5 degrees as well. So you can see here, just by working your way around, you are able to solve all of the different angles using your rules. So you'll need to have these rules memorized and then practice applying them. Okay? So with that, I am going to sign off for the evening. See you in class.